Day 836 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 1563, Stone Game 5. The difficulty level is hard, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, hype, subscribe, comment, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. There are several stones arranged in a row, and each stone has a value associated, or each stone has an associated value, which is an integer given in the array stone value. In each round of the game, Alice divides the row into two non-empty rows, i.e. left row and right row. Then Bob calculates the value of each row, which is the sum of the values of all of the stones in this row. Bob throws away the row which has the maximum value, and Alice's score increases by the value of the remaining row. If the value of the two rows are equal, Bob lets Alice decide which row will be thrown away. The next round starts with the remaining row. The game ends when there is only one stone remaining. Alice's score is initially 0. Return the maximum score that Alice can obtain. All right, y'all, so that may seem a little bit confusing at first. So let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, the input stone value equals an array of integers 623455. The output is 18. Explanation says in the first round, Alice divides the row 623 and 455. So Alice is going to break the rows up like this. Boom. Then the left row has the value of 11. That's this right here. 6 plus 2 plus 3 is 11. And the right row has a value of 14. That's this right here. 4 plus 5 plus 5. Bob throws away the right row and Alice's score is now 11. So Bob gets rid of this. Well, let's boom, copy and paste this over here so y'all can see a little better. So boom, this is it gets split up like this. Bob chooses this row to get rid of. So sorry y'all, let's just copy and paste it. So that means Alice is going to get 11 points. This 11 goes to Alice, and then we have a new, sorry y'all, we have a new array right here. So then it says in the second round, Alice divides the row into 6 and 2, 3. So now this row is being divided like this. 5 right here, 6 right here. This time Bob throws away the left row and Alice's score becomes 16. So this time Bob is going to throw away the 6. Alice, 11. Hold on. 11 plus, oh, okay, yeah, so this the 5, we get rid of the 6, then 11 plus 5, so now Alice's score is 16. And this is the new row that we're looking at, or the new array. The last round, Alice has only one choice to divide the row into 2 and 3. Bob throws away the right row, and Alice's score is now 18. So Bob is going to get rid of this 3. 16 plus 2 is 18. It says the game ends because only one stone is remaining in the row. Boom, and that was 18. So once again, we're returning the maximum score Alice can obtain. In this case, it's 18. In this case, it's 28 because we could either take these 4 sevens or we could take these 4 sevens when we split in half. In the end, it's going to be 28. And in example 3, our input stone value is an array of integers 4, and this time the output is 0 because we cannot split this in half. It says the game ends when there's only one stone remaining. Alice's score is initially 0. So here it's only starting with one stone, so the score stays 0. So boom, y'all. I hope that makes sense. And now that we understand the question, let's get into the fun part, the actual solution. The solution is not that difficult at all. Now, first thing we're going to get is the number of stones. So we're going to say let n equal stone value dot count. Boom. Now we're going to get the prefix sum array. And prefix of I is going to store the sum of the first I stones. This allows any subarray sum to be calculated in big O of 1. So we're going to declare a variable called prefix sum. set that equal to an array of integers. We're going to come outside of that, open up the brackets, and we're going to say repeating colon 0, comma, count, colon, n plus 1. Boom. Then we're going to build the prefix sum array. So we're going to say for I n 0 dot dot less than n. We're going to open up the brackets, and we're going to say prefix sum square bracket I plus 1. Come outside of that equals prefix sum square bracket I, come outside of that, plus stone value square bracket I. Boom. Hold on. Boom. Then we're going to do the memorization table, which is going to store the maximum score Alice can obtain from the subarray, and nil means this sub problem has not been solved yet. So we'll come underneath this, declare a variable called memo, and we'll set that equal to a 2D array of integers. Come outside of that, we'll open up the brackets, and we're going to say repeating colon square bracket and question mark. Come outside of that, we're going to say, open up the parentheses, say repeating colon nil, comma, count, colon, n. Come outside of that, comma, count, colon, n. Boom. Now we're going to return the maximum score Alice can earn from the subarray. So we'll come underneath this, and we'll say func dp parentheses underscore L, colon, int, comma, underscore R, colon, int, come outside of that. It's going to return an integer. Boom, and a single stone cannot be split, so no more points can be earned. So we're going to say if L equals R, we're going to open up the brackets, and we're going to return 0. Then we're going to return the cached answer if this subproblem has already been solved. So we'll come underneath this, and we're going to say if let cached equals memo square bracket L, come outside of this, square bracket R, boom, come outside of this, open up the brackets, and we're going to say return cached, boom. Then we're going to store the best score obtainable for this range. So we'll come underneath this, declare a variable called max score, set that equal to 0. And then we're going to try every possible split position. So the split occurs between I and I plus 1. So we're going to say for I n L dot dot less than R. We're going to open up the brackets, and we're going to say let left sum equal prefix sum square bracket I plus 1, come outside of that, minus prefix sum square bracket L. Boom. And then we're going to get the sum of the right partition, so we're going to say let right sum equal prefix sum square bracket R plus 1. Come outside of that, minus prefix sum square bracket I plus 1. Boom. And if the left partition has the smallest sum, Alice must keep the left side. So we're going to come underneath this, and we're going to say if left sum is less than right sum, we're going to open up the brackets, and Alice earns the left partition sum, then continues playing on that partition. So we're going to say max score equals max, open up the parentheses, max score, comma, left sum plus dp, open up the parentheses, L, comma, I. Then if the right partition has the smallest sum, Alice must keep the right side. So we'll come right here on the if, and we'll say else if left sum is greater than right sum. We'll open up the brackets, and Alice earns all the right partition sums. So we're going to say max score equals max, open up the parentheses, max score, comma, right sum plus dp, open up the parentheses, I plus 1, comma, r. Now, if both partitions have the same sum, Alice may choose whatever side leads to the larger future score. So we'll come underneath this, and we'll say else. Then we'll open up the brackets. We'll say max score equals max, open up the parentheses, max score, comma, left sum plus max, open up the parentheses, dp, parentheses, L, comma, I, come outside of those parentheses, comma, dp, open up some more parentheses, I plus 1, comma, r. Boom. Now, we need to come down here, and we need to save the computed answer for this range, so we can say memo, square bracket L, square bracket R, equals max score, come underneath this, and we need to return the best possible score by saying return max score. But remember, this is just the helper function, so we still need to call this helper function to solve the problem using the entire array. So we're going to say return dp, open up the parentheses, 0, comma, n minus 1, y'all. Boom. Let's give it a run. Make sure it runs. Let's see. Let's see. So this should be hold on. Oh, so this should have a question mark as well. So now let's run it, see if that does it. See if that does the trick. It's accepted, so let's go ahead and submit it. Make sure it's still accepted after we submit it. Boom, and look at that, y'all. 526 milliseconds, 1250 beats 12. Beats 12%, 12 and 50% of the users. So, well, 12.5% of the users, y'all. So with that being said, before we go, make sure you get one more look at the code. This is the top. This is the middle. And this is the bottom, y'all. And yeah, with that being said, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.